Hello students, good afternoon.
Good afternoon, sir.
Good afternoon,
Good
sir.
afternoon,
Is the screen visible?
yes, sir.
Yes, sir.
Okay, so now we have 76 students in this lecture, so we can start now. So let me start this second chapter, you can say, which is based on the fluid statics, the very first part of the mechanics, that is statics, the statics of the fluid. And as I told you that this fluid mechanics contains the three parts, that is static, kinematics and dynamics. So this is our first statics part. So let us start this now. So I think here let me explain briefly about this. Okay, because actually that we have already discussed briefly. But before starting this statics, we should discuss this so that it will be clear that what things is going to cover in this in the future lectures. Okay. So this is our fluids, basically gas and liquids. Okay. It's in the section of fluid you will find this. In the mechanics you will find like statics and dynamics. Okay, so in the statics means here you will find that there is a equilibrium condition. Okay, means static means definitely static means it's equilibrium, so you will find that the net force will be zero. But here in this case of dynamic, we know that dynamic is only possible when there is an unbalanced force. If there is a balanced force, then it will be like a static. So here you will find this condition. Okay, during your statics and dynamics. Now let's discuss this gas and liquid. So this actually we already familiar that what is gas and what is liquids here. Okay, but the properties which play the role which we have discussed is this that we have already discussed, and these are the properties which play the significant role in the fluid mechanics, you can say, and that we have already covered in this introduction chapter, which has already been completed. Okay, so now moving to again here in the state in the dynamics part, let me discuss the first in the dynamics. So in the dynamics part is further divided like laminar flow. These are the type of flow. Okay, that we will discuss in the future lecture. What is this laminar and turbulent? And this is your turbulent flow. So these are the type of flow. And again, they are based on the properties of the fluid. The flow is divided like viscous flow and inviscous flow. So viscous means when this is not equal to zero, and inviscous means when viscosity is zero, like potential flow. Okay. Then comes a compressible, where the density means the you can say the change in the density is not equal to zero. And here in the incompressible, your density change is zero. There is no change, means it is incompressible. Density will not change. Here, steady, okay, is means when your properties or your flow is constant with respect to time. Okay, means that is means time dependent. Here in this case is zero in the case of steady. But here in the case that means the variation of like the flow parameters like velocity, like properties, all will not be zero, means it is unsteady. It depends on the time. With time your flow behaviors is getting changed. So these are how these dynamics is classified. So your dynamics, okay, which is the rest of the course after this fluid statics, the rest of the course will contain this type of flow, different types of flow. Means your rest of the syllabus will be based on these concepts. Okay, so that is your fluid dynamics, which is the rest of the course after this statics. But yes, in the statics we are going to start the statics. So let us discuss what is this statics basically. So static, in this static we are going to discuss like the stability. Obviously, if there is a static, there is no force. So only force means in the form of pressure you will find. Means there is only the static equation only contains the pressure actually, because pressure will act only there because there is no motion. So only you will find the term that is called the pressure. And yes, buoyancy play the role, and also the buoyancy plays the role in this stability condition. What is buoyancy? It is an upward force, a thrust you can say, which always act in the upward direction. When you put any object in the fluid, you will observe that you will feel that their weight is getting lower. Means if the fluid density is higher, then you will feel much lower weight of that any object. Why? Because the fluid has a property to exert a upward force, which is called the buoyancy. So that is your buoyancy actually, and that buoyancy play a significant role in the stability, finding the stability conditions. So these are the things which we are going to discuss in this static part. So that our chapter 2 is static parts. And after this, the rest of the course is totally based on this dynamics. So it means that dynamic is a bigger part, okay, in comparison to fluid statics. Okay. Now, so let me discuss this your fluid statics. Definition we are already familiar with this. It is the branch of the fluid mechanics that deals with the behavior response of the fluid. When the fluid are in the rest, means when the velocity is zero, there is no velocity. Okay. Or in rigid body motion, means there is no relative motion between the adjacent layer. You can say that is your rigid, means if uh, there is a motion between the adjacent layer, then you can say it is dynamic part. So in the rigid body means there is no relative motion. Like all of you are familiar with this rigid body because you have already completed the solid mechanics. So rigid body motion means when there is a no motion of the adjacent layer, relative motion you can say. Like if this is your solid object, you can say, and if these are the different layers, so all will move with the same displacement. But if the things like this, say one layer is moving ahead of the another, then this is not the case of the rigid body. Okay, so the static means it is their layer is in the same position related to each other. So that is the view of statics. So in both instances, there will be no shearing stress because there is no motion. So if there is no relative motion between the two layers, so there is will be this means the gradient, the velocity gradient, which we have already discussed, will be zero. So if this will be zero, so according to the Newton's law, you will find that this will be zero. Okay, so if there is no motion, then shear stress will not act. So this is a very important point. Sometimes it has been asked that what is the shear stress during the case of a static? So your answer should be simply that it is zero because there is no relative motion. So now the only force means if this is zero, okay, if this is zero, then what is the force there? The question is this. So yes, the force, okay, the force that develops on the surface of the particle which is due to the pressure on. So the only force which plays the role in the statics is the pressure. Pressure exerted, you can say the pressure exerted by the weight or volume of the fluid on the surfaces. Like if the fluid is contained in the container like this, if this is the fluid, so obviously the pressure will be a pressure will be exerted by this fluid medium on this wall, on the surface of the container. So that is the only force which comes into the picture in the case of the statics. Okay, so pressure, I think all of you are familiar, means the average, what is this pressure? It is, as I told you, that it is the normal force exerted per unit area. And it is, I think, it is a very general notation of the pressure, that is P. I think it is worldwide known by the P, the notation P. Okay, so this is very common. Okay. So thus our principal concern is to in this chapter, in this fluid static, okay, is to investigate the pressure. Investigation of pressure. We can say in one line, okay, investigation of pressure. So fluid statics, in other words, it can be defined that it is just the investigation of pressure. What is the pressure acts during the different case of the statics, you can say. Okay, so it will means that fluid statics contains the investigation of this pressure. Okay, and its variation throughout the fluid. Okay, and the effect of pressure on the submerged bodies means all the things are related to the pressure. And mathematically, I think all of you are familiar with this, that force per unit area. Yes, the SI unit here, that is your Newton per meter square, and also it is denoted by pascals. Newton per meter square means Pascal. And as I have already discussed this, I think foot that pound system. So that LB means that is pound. Okay. So that LB, this is also called the PSI. Okay. Pound force per square inch. Here it is called PSI. Okay. So that is this. In CGS means the in the dyne per centimeter square, which is called the CGS systems. It is, and this is important relations. You are going to use this in your numerical problem. That 1 bar is equal to 10 to the power 5. So all the time you will need this. You need to change in the terms of Newton per meter square to maintain the homogeneity of the unit. So that is important that you are going to use. Okay, so this is what the brief, you can say the brief introduction of the statics. Okay. It's, I think all of you are familiar with this also, Pascal's law. How many of you are familiar with this?
So this was states that
Yes, sir, we are familiar with it.
Yeah,
So,
familiar with
it,
I
sir,
know
if
this is
any,
a very common topic of the, I think in of the intermediate, I think of the 11th, I think 11th standard.
yes,
So
sir.
all of you are, I know all of you are
yes,
familiar
sir.
with this. But yes, because it is our static part, and as we discussed that in the this static part, the pressure is the only force which always act. So obviously, if the term pressure is coming into the picture in this static chapter, then obviously Pascal's law will play definitely will play a role there. Okay, because Pascal's law is also related to the pressure. Means the pressure which acts from all the direction is same. That is the Pascal's law basically. I think there is a derivation of this Pascal's law, means the mathematical formulation you can say. Okay, means these are the very conventional method of the derivation of this Pascal law. I think all of you are familiar with this, that there is a wedge shape having dimension like dx, dy, and dz. Okay, these are the dimension, and a pressure here is acting on this surface, and as we know that this pressure will act normal to this surface. So if this is normal to this surface, obviously it will make some angle with the x and y like alpha. So you can see this picture. Okay. Now what our next task to do in this derivation of this Pascal law, we have to take like x force, okay, due to this which is acting from the x direction, and due to this you can say the fluid over that element like here, because this element is surrounded by the different molecules which exert here the pressure here. Okay, and there is another, because we know that the pressure is acting from all the direction. Okay, so that we have to take the I mean, pressure from all the directions here, and then we need to balance these forces. Then you will come out with the result that px is equal to py is equal to pz is equal to p, simply the pressure which is acted here. So both means from all the direction we will find this relation. So the main task in the derivation is to balance this, like means the force in the x direction means force in the x direction. So what is the force in the x direction? Look at this. This is your in the x direction, and this is in the x direction. This is moving in this direction, this force, and this is moving in this direction. So obviously these two will be, this should be balanced, because there is a static condition, because it is there is no force. So it means it is static. So When static will maintain, when the forces from all the direction will be means the resultant force should be 0. So we know that the static condition is this. I think all of you are familiar with this static condition. Okay. So when we will put this, okay, these are the, and obviously there is a weight of this, but if you are considering a very light element, a small, so that weight is actually negligible here. Okay, so this is how, let look at here. Okay, this one means for the x direction. This is for the x direction, you can say. This is for the x direction, this is for the y direction. Okay, so look at here, it is the balancing of this force. Here I think it will be x. Okay, here it is x. I think here there is a typo error. So that force will balance this force and ultimately it will maintain a equilibrium when it will come out 0. So when we will do this task, ultimately we will come out with this. This is totally a mathematical calculation. You just need to put here cos alpha. So look at here. This is your alpha. So cos alpha you can substitute with this, that is dy by, because this is your dy. This is your dy and this is your dl. Okay, this is your dl. So that dy by dl. So that alpha will be replaced with dy by dl, because this is your base, this is your hypotenuse. Okay, and cos alpha is base by hypotenuse. So that when we will put this, we will ultimately come out with this relation. Similarly, do the same task, but here you take the means, because in the vertical direction there will be some weight also, because but your element, this is a very small element, so weight is almost like 0. So when you will substitute, you will again come out with this. And do the same task for the z direction also, you will come out the same, means that is z is equal to p. So this is how you will come out with the this Pascal law. Okay, I think all of you are familiar with this derivation also, but we are doing a quick revision. Okay. But if you have any question, then you can ask. Anyone is there? Should we move further?
Yes, sir.
Okay. Okay, so this is your basically the main equation of the Pascal's law. Okay, so now let me discuss this. This is important actually. You can say the different type of pressure actually. You can say this topic is actually the different type of pressure generally used. Okay, different types of pressure. So it is not the different type, means it depends on the reference, you can say the reference. Okay, so it is the different type of pressures you can say, and that these pressures is used during the measurement techniques. Okay, means you have to be very careful that which pressure you are considering during, like also in the numerical solution. Okay, you need to be very careful that which pressure is this. Okay, like this. So after discussion, that will be clear to you that what are the pressures actually. So let us discuss this topic. This is very important. Okay. What is the different types of pressure which is generally utilized? So first we consider the pressure which is the atmospheric pressure. We will define one by one. Okay, here is the definition, so that we will discuss. Now we have the gauge pressure. Then come the vacuum pressure, which is the negative pressure. Why it is negative, we will discuss. And the absolute pressure. So we have this four pressure which is generally used during the measurement of the pressure exerted by the fluids or any medium. Okay. Now, the first, what is this atmospheric pressure? So basically, it is the pressure exerted by the atmosphere. Like we have our own atmosphere, like this, where we are sustaining, where we are living on this earth is our atmospheric. So atmospheric pressure means actually, if this is your earth, okay, this is your earth surface, and there is a air surround, means everywhere there is a air. Okay, we all are familiar with this. Everywhere there is a air. So why it is called atmospheric pressure, and who exert the pressure? The question is, sir, who exert the pressure in this atmospheric pressure? So it is the air, because our environment is full of the fluid. What is that fluid? So it is air. Air is the fluid here which exert the pressure. And that's why it is called atmospheric pressure, because fluid always exert pressure. If there is a fluid, then it will exert pressure. So in our environment, there is a air, so definitely there will be some pressure. What is that pressure? It is atmospheric pressure. Clear? Hello? Say yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now the next come the gauge pressure that we will discuss. Okay. Means we are going to elaborate this again further. But here the definition is means the pressure which is more than the atmospheric pressure. Like you are living in a very standard, like in a room. So the pressure exerted by this air is your atmospheric. Totally. Because there is no other force. But suppose you are keeping a book on your hand. Okay. So what happens then? Anyone can tell me what pressure will be there? Just use your common sense, because this is based on the common sense. Anyone can answer
So
this?
can you please repeat, sir, what you have said?
Okay, let me give some
The pressure
example.
of and atmosphere.
Now I have switched on my camera actually. So let us suppose I have a book here. Is this visible to all of you?
No, sir.
नो
No.
सर
No, sir,
सर
it's not visible.
बैकग्राउंड चेंज है ना आपका, उसकी वजह से ब्लर हो रहा है.
But
सर बैकग्राउंड
background is different.
Yes, sir. Please choose your
Okay, I
original
think
background.
there is some setting I think is there. It's a camera setting I think. But is it not visible? Because here I am able to see my photo here.
सर it's blur sir.
ओके आई थिंक आपको ये बुक नहीं दिख रही होगी. ओके ओके आई अंडरस्टैंड.
Yes, sir.
ओके आपको मेरी फिगर जा रही होगी.
Exactly so.
यस
What
सर
did you?
हाँ मैं समझ गया.
Yes,
ओके यस यस दिस इज द प्रॉब्लम एक्चुअली.
सर फेस की फिगर आ रही है फेस की वो आ रही है
सर वो कैमरा पे क्लिक करके आप रिमूव बैकग्राउंड कर सकते हो. नीचे ऑप्शन आता है.
हाँ वही मैंने कैमरा पे डायरेक्ट नहीं होती है. आई थिंक ये आपको डिवाइस की पे जानी पड़ेगी.
सर वो जो 3 डॉट्स है ना सर, उसमें एक अप्लाई बैकग्राउंड इफेक्ट करके है कुछ सर, उसमें किया होगा शायद आपने.
वही है. आपको ये शायद कभी मैंने चेक करने के लिए किया होगा. तो वो आ गई होगी. Now it is visible.
Yes, sir. Now it's visible.
Yes, sir, it is visible.
Okay. So now you can see this book here. Okay. Just see
Yes,
this.
sir.
So obviously, if there is some weight of this book actually, and it will exert some force on my hand. Okay. But along with this, there is some air just above of this book that will also exert a pressure. Means, what was the initial condition of my hand? It is this. Means, what is the pressure is there initially?
So atmospheric
Atmospheric
pressure.
pressure.
Now, if I am doing this,
Gauge pressure.
combined
Means
effect
atmospheric
of
plus the pressure of book.
plus that pressure which will exert by the
Weight of the book.
so it is combined. So it means the gauge pressure always greater than the atmospheric pressure. So what is the gauge pressure means? It is that extra pressure which is exerted by that. You can just consider this as a fluid, because we are studying fluid, not the solid. So we have to take the example, because I don't have the fluid. Okay, and I can't take the fluid at this time. So you need to consider this as a fluid. Okay. So means it is that extra pressure which is exerted by the fluid.
That
Means
fluid.
we have to consider the pressure exerted by the fluid plus atmospheric pressure. If you are measuring the pressure in the environment, means in the atmosphere, so you have to ask, sir, whether this is gauge pressure. So if someone asked that this is the gauge pressure, so you need to be very careful. Gauge pressure means the pressure, it is that pressure plus atmospheric plus the exerted by the your any fluid. So that is your gauge pressure. Okay.
Yes, sir.
Okay. Now
Yes, sir.
let me move further. So here you can see, here is we have this equations like this, so that we are going to utilize basically, but let me complete all the definition. Okay, and then we will discuss one by one. Now the pressure which is less than the atmospheric pressure, so less than means as soon as we started moving down, it is called the pressure less than the atmospheric, and it is called that there is a start of the vacuum. We will discuss. Okay, this is just consider the definition. Pressure measure relative to absolute zero. So now let me take this figure and let me elaborate this one by one. Okay, you have got the idea of atmospheric pressure. Now in the measurement of the pressure, actually we have the two reference line. Okay, look at this dot line, this is our atmospheric line. Okay, means it is that pressure. I think this is known, 1.01 bar. I think all of you are familiar with this. Is this correct?
Yes, sir.
Yes, sir. Yes,
So
sir.
in the atmosphere,
Yes, sir.
you will always feel this pressure. You are under this pressure always. If you are living in this atmosphere, it means you are under this pressure. This is fixed. So this is our one of the reference line. Then come another reference line. Look at this black bold line. This is your another reference line. So here atmospheric means here we have a some value, means some positive value. Okay, this is called our some, there is some means the finite, not the positive, because there is a negative also which we will discuss. You can say there is some finite value of this atmospheric pressure, but here absolute means the complete zero pressure. So we have the two reference line. One is atmospheric, because we have to consider atmospheric because we are living in this atmosphere. Okay, and there is another reference line which is completely zero, means there is a complete zero vacuum, you can say complete vacuum, absolute vacuum. This is called the absolute. This line is called the absolute vacuum. Absolute means totally zero. Above this line, as I told you, that it will be gauge pressure. It will be a gauge pressure. The atmospheric plus extra pressures means if we are starting from this line, absolute vacuum, and take this line, what is this denoting? Means let us suppose here we have some pressure, means above the atmosphere we have some this extra pressure. So a P absolute will be like this atmospheric. Okay, sorry, P atmospheric plus P gas pressure. So this is our gauge pressure, means it is that extra pressure which is above the atmosphere. So obviously absolute will be what? Atmospheric plus gauge, because absolute starts from this. Okay, so this is your one of the relation between this. So here you can see this is the equation. Next. Next comes, let us discuss the vacuum. What is vacuum? As soon as you start moving down of this atmospheric pressure, your vacuum started. Okay, your vacuum started, but yes, the pressure is still not, this is not zero. But yes, what means your pressure is less than atmospheric pressure. So vacuum means the pressure less than atmospheric pressure. And amount means it will vary between this from 0 to this atmospheric. So as soon as we will start goes down from the atmospheric pressure, it is called vacuum. But at the absolute line, you will get a complete vacuum, means total pressure is 0. Below the atmospheric, that doesn't mean that pressure is 0. You are below the atmospheric pressure, not the 0 pressure. But absolute 0 means complete 0. There is no pressure, totally vacuum. Because we have here, we have some value. Okay, and to make it 0, we have to go down up to a good level. So that is your vacuum. So you can see now this equation. In this case, what is your P absolute? Obviously, because P ATM is greater, and that you have to minus vacuum. Sorry, here it will be P vacuum. So this will give you absolute. Look at here how. Okay, this is your absolute in the case of vacuum. So formula of the absolute is, look at here. This is your absolute. Sorry, this is your atmospheric pressure. Okay, this is your P ATM. To find the absolute, we have to subtract this pressure. So when you will subtract this line, this will give you this absolute. So P ATM minus P vacuum. So this will give you absolute during the case of vacuum. So during the case of vacuum and during the case of gauge pressure, your formula for finding absolute pressure is different. That you need to be very careful for during finding of the pressure. Whether you are finding above the atmosphere or below the atmosphere. Accordingly, you need to use the formula. Any question?
No, sir.
सभी को समझ में आ गया?
Yes,
Yes,
sir.
sir.
Yes, sir.
I think we can move further, right?
Yes, sir.
Okay,
Yes,
so
sir.
let's discuss the another. As I told you that in this statics, it is the pressure which will play the significant role. Means all around we will revolve all around of means with around this term, that is pressure actually in the statics. Okay, because there is no other force. The common, very common sense. So let us develop the equation, means the equation for finding the pressure in the case of fluid. Okay. So this is here, this is a very short technique. We have different technique also, so through which we can develop this, but this is a very general and common practice of finding the pressure. So what happens here, you have a tub here. Okay, just consider a container, just like a tub. Okay, and you are placing a cylinder here, means you can say the cylinder means not the solid cylinder, it is a hollow cylinder. Okay, so what will happen, a fluid will come into this cylinder, and obviously it will start exerting the pressure. Obviously fluid, because if there is a fluid, so it will exert pressure on this. Let us consider this at this surface, it will exert the pressure. Okay, so this will exert a pressure, means, and what is the another force is there, that is weight. Okay, so fluid, obviously these fluids is exerting some pressure there. It means that pressure on the base of the cylinder will be equal to the weight of the cylinder. Means these two force will balance to maintain the static condition. If they will not maintain this equilibrium, then there will come a motion. But if they are in equilibrium, it means obviously the forces are balancing there. So what are the forces there? Obviously the two force, one is weight and another is the force which is applied by the fluid, which is generally taken in the terms of pressure. Okay, so just now consider the mathematical part. Okay, what we have discussed is the theoretical. Now let us the mathematical. So here h is the height of the liquid in the cylinder, means this is our h actually, the height of the liquid in cylinder, and the area of the cylinder of the base, means this is your area, and a specific weight of the liquid, that is you can say means the gamma, which is equal to rho z, and P is the intensity of pressure. So if it is pressure, so we have to multiply with the area, so you will come with the answer of the force Means what is the force acting here just at the base. So this is your pressure, and this pressure will be balanced by the weight. Okay, so just expand this, that is rho into z into area into h. So look at here, area into h is actually volume. So rho into volume into g, you can write down that is m into g, because rho into v is mass. So this is actually the pressure force is balancing by the weight of the fluid, and this area is common, so you can cancel out. You will come out with this equation, which is ultimately equal to rho z h, because your gamma is equal to rho z, isn't it? So this is how you can
Yes.
find the pressure. Okay. Now we have another this. Okay. Let me elaborate this further. This the same thing, but in the another sense. What is that another sense? That I will reveal in the last. In the during the finding, means the finding of this pressure head. Why it is called head? Okay. That I will give
Sir,
you. Yes. Hello.
sir, can you go to the last slide?
This one.
Yes, sir. Sir, in the right hand side, what was before A? Gamma?
Before, yes, gamma. That is a specific weight. Okay. There is some mismatch, na?
Yes,
Okay.
sir.
This is okay. Yes, you are correct. You are very correct. This is gamma. You are very actually in somewhere you will find this omega, means like the W you can say. Okay, and in somewhere you will find this gamma. So these two are the very common notation of the specific weight, you can say. You will find this in the books. I think due to that this has occurred here. But okay, now we can move to this. Okay, so during the finding of this pressure head, means the finding of this pressure head, it is called a hydrostatic law. Okay, so what is this hydrostatic law? The rate of increase of pressure in a vertically downward direction must be equal to the specific weight of the fluid at that point. That is actually the hydrostatic law, which we have already derived here, means which we have already discussed. So what we have discussed here is actually this hydrostatic law, means the rate of pressure in a vertical downward direction must be equal to the specific weight. Pressure is actually, look at here, is equal to the specific weight. Okay, now elaborate this. How? Means just let us prove this this hydrostatic law, whether this is correct or not. Okay, so to prove this law, hydrostatic law, we have a fluid element. You can say this is our fluid element. So obviously, if this is our fluid element, and we know that the pressure act on this fluid element from all the direction. Okay, so here we are interested in finding this vertical, means the vertical case, because here the pressure from all the surroundings for this horizontal, you can say this horizontal will be equal, but here because there is a height difference, look at this, we have a certain height here like h, as we have seen here, there is a h. Okay, so that need to find what this height difference is affecting in the pressure. So that's the first point. So at this phase LM, the pressure will act like P into del A. Here del A is our cross-sectional area. Just on this surface, on the another opposite surface, that is ST, okay, means the difference between these two surfaces in the height is like, you can just consider that is del. Here in this case it is del Z, not the H. Okay, so here you need to consider del Z. So okay, now we know this pressure here is P into del A, and up to this point obviously the pressure may vary. So how it will vary? At this point our pressure is P, and with the height there is some variation in pressure with del Z up to a distance del Z. Is this clear? I'm asking again. Is this clear?
Yes, sir.
If anyone is
Yes, sir.
here,
Yes, sir.
Yes, sir.
Okay,
It is
how it
clear.
is varying? I think all of you are.
No, sir. Can you please explain it again,
What is
please?
the pressure here? P.
We did.
Okay, just say yes.
Yes, sir. Yes.
So, and we are moving here in the downward direction. Up to what distance?
Delta Z.
Delta Z. So, okay. So that is our P. Obviously, this pressure will be there, right?
Yes, sir.
So that P and plus what are the pressure changes for this height del Z? Because your pressure is changing with respect to del Z, so we have to consider this dP with respect to, means del P with respect to Z up to which height?
Del Z.
Clear?
Yes, sir.
And then when you will multiply with area, it will come out force. Okay. So look at here. It is
Yes,
your
sir.
force acting on the LM phase. This is your force acting on the ST phase. Okay. And we know that both will balance because one will exert on this surface, another will exert on this surface. So now for the equilibrium, means for maintaining the equilibrium, we have to find this. It is in Y, so we have to apply this. So when we will apply this, means the, look at here, this force will act in the downward direction, this will goes in the upward direction, and also there will be weight that is like mg. Okay, in the, that mg you can change in the terms of a specific weight like here gamma. Okay, so there is a weight in the downward direction and this force in the downward direction, and this is in the upward direction. So look at here, this term will be cancel out, pp. Okay, and you will come out with this with area. So here it is area and this term and this weight term. Okay, and further when you will go, when you will take this the ultimately it's this. Okay.
Excuse me, sir. Sir, am I audible? Sir, my question is that this hydrostatic law is the most basic law because sir, क्योंकि मतलब ऐसा मतलब क्योंकि जो हम डराइव कर रहे हैं और गामा इज इक्वल टू रो जी ला रहे हैं सर उसी से हमने उसको एज अ रिजल्ट यूज किया जो हमारा दो पिछला डेरिवेशन था
पिछला दो कौन सा ये
एक सर जो पिछले क्लास में भी एक हमने कुछ डेराइव किया था उसमें गामा इज इक्वल टू रो जी हमने यूज किया हुआ था और मतलब यहाँ पे भी किया हुआ है तो
तो
लेकिन अभी
ये
जो
तो
प्रूफ
प्रेशर
किया उसको
रिलेशन नहीं थे बच्चा वो ना, वो तो स्पेसिफिक वेट है। वेट मींस दैट इज, आप इसकी बात कर रहे हो। तो एम इज
तो
लाइक
सर यहाँ पे मतलब
यस,
प्रूफ बस इतना करना है कि अगर सर थोड़ा सा डिस्टर्बेंस
इट्स ओके। आप
सर वो
एक्चुअली बोलना क्या चाहते हैं वो समझ नहीं आ रही है। आप जो बोल रहे हो तो ठीक है, हम तो स्पेसिफिक वेट प्रॉपर्टीज तो पढ़े ही हैं, बट ये हमने ये पिछली लेक्चर्स में कब पढ़े हैं? ये तो
ओके मतलब यस सर सो मींस इस लॉ को हमने प्रूफ किया सर माय मिस्टेक टुडे देयर इज लिटिल डिस्टर्बेंस
नहीं, इस लॉ का मतलब ये है कि डेट प्रेशर इज वेरी विथ हाइट।
ओके सर आई गॉट इट
Okay,
सर ओके
that pressure is varies with height also. अभी ये complete नहीं हुआ, means this change in the pressure, if you look at this, what is this actually? This is the density. If there is no change in the temperature, the significant temperature, okay, then it means that density will constant. What is this G? It is also constant.
acceleration due to the
So
gravity it is
ultimately
also
means that this actually means the change is actually the constant with respect to this. And if you want to find the pressure at a certain height, like from this surface, if this is your surface and you are trying to find out the pressure at this point, means like let us this height is h like 5 meter, just take the 5 meter, okay, of water. Just take the water. What is the density of this water? It is 1000 kg. We all know this. So I asked, what find the pressure at 5 meter at the 5 meter depth of the water. So how you will find, just do this, that is either you can use simply, that is rho g h here, okay, or you can use here and just take the integration, means if you are considering this, that is del p is equal to del z into rho, so then take this, that is from point 1 to point 2. If you are finding this is your point 1, this is your point 2, means this equation, with this equation you can find the pressure, means between any 2 point like this. Okay, so this is because this is in the differential form, and this is your very specific, means the from this you can find out for any particular point, but here you can find out with this equation, you can find out for the pressure difference between the 2 point also. Okay, these two are the same thing. Okay, because this is in the differential form, so it can give you the difference between the 2 point. But look at here, this is not in the differential form, it is just a linear relation. And here it is, that's why it is called differential. Differential means it can give you the difference between the 2 points. And so it means whatever the changes, okay, with respect to 2 points or 3 points, means from this to this and this to this, like 1, 2, 3. Okay, so 1 to 2, okay, and then 2 to 3, that change will be constant, because the change is only depend on the density and z. Both are the constant. So change is the constant. But if you want to find out the pressure at a particular point, then just use this. If you want to find out the pressure between the two different 2 point, you need to use this. And accordingly, like here, difference between 1, 2, and that will be equal to like from 1 to 2 for this del z and rho's. That's simple. Okay.
Yes, sir.
Yes, sir. Got it, sir.
Okay, so we can move further.
Yes, sir.
Yes, sir.
Yes.
Sir, excuse me, sir. Sir, how can you say, sir, that change is constant, sir? Sir, gravity is, sir, maximum at surface, sir. It decreases, sir, when we go below the surface or when we means above the surface of
Surface
Earth.
means
Sir, when we go down the Earth, sir, it decreases, sir.
dear students, on this Earth surface, your gravity is considered constant. Okay, until and unless you are not going out of this atmosphere, like just out of this space. Okay, gravity is considered constant on this
Okay,
Earth
sir.
atmosphere. It's not changes here. It is constant and parallel also. Okay, so don't bother
Okay,
about
sir.
this. If you are changing the gravity, it means you are changing your space. You are moving from Earth to either a good level of height from the Earth atmosphere. You need to leave your atmosphere. Then it is considered that there is a very significant change in the gravity. Yes, there is a change. Means that is very slightly. Means for a significant change, you have to change the good level of elevation. That happens. That happens with the elevation. You are very true, but for a very good level of elevation, not for the Earth atmosphere actually. Okay, you are actually correct,
Okay,
but
sir.
what
Thank
I
you,
am
sir.
talking is for the Earth atmosphere. Okay. So okay, now I think our time is over, but okay, let me complete this atmosphere. I think atmospheric pressure of all of you are aware because we have already discussed. But yes, this atmospheric pressure actually counted in the different, you can say the unit or in the different manner, like here, this is 101.3. The unit is like kilonewton per meter square. Here you will find bar. Then, as I told you, this is actually equal to, that is LB per square inch. That is pound foot per square inch. And also it is counted in the terms of means the mercury height. Okay, from the reading of the mercury height, means this is actually the pressure exerted by the atmosphere, means 76 mm of Hg. Means when you will put a mercury here in this, that we will discuss later. Okay, don't bother about it. and in the terms of like feet and the water like here. Okay, so all these are here is the, you can say, the different matter of for the denoting the atmospheric pressure. You can find all these in the numerical problem. Anyone you can find. Okay, so don't be
Sir.
bothered. What is this? Yes,
Sir, what is PSI?
I told you that pound force per square inch. I discussed this in
Okay,
the
sir.
very first class of fluid mechanics, pound system. Okay, LB, pound
Okay,
force.
sir.
LB means that is pound force. Okay, there is a relation that I have already discussed in the first class. Okay, I actually जो आप लोग I think सभी बाइक चलाते हो, right? बाइक और फोर
Yes,
व्हीलर,
sir.
टू व्हीलर, आप जब
Yes, sir.
प्रेशर, ये आज भी ये इसलिए इसकी मैं डिस्कशन करता हूँ, आज भी जब आप जाते हो बाइक में एयर फिल करने तो वो इसी में रहती है उसकी मीटर, ठीक है? आई थिंक व्हीकल्स में लाइक 30 to 35 psi की प्रेशर होती है. And you can see here the pressure of atmosphere is 14 point something, and in the your vehicle it is means I am talking about the four wheeler. I am because बहुत दिन से बाइक नहीं चले तो मुझे नहीं पता, but फोर व्हीलर में जनरली आपकी ये रेंज होती है. Okay, so this is I think water and gas. I will discuss that. Okay, this is the matter of next lecture that I will discuss. But okay, we will stop here. Okay, if you have any query, then you can ask. Okay. Okay, then I will take the attendance. Viles is present. Abhishek
Yes, sir.
Jangir is present, and 3, 4 Abhishek is present. Adarsh, Ajay, Azit, Akash, Amandeep, Amar, Bhardwaj, Amit, both are present. Anand Zain, Aniket, Anirudh, Anjali, Ankit, Anand, Archit, Arjun, Arshprit. Aryan Dwivedi, then Asis Meena, Asutosh, Atul, Ayush, Ayush. Ayush is absent. Ayushi is present. Chaitanya, Charan, David, Deepnan, Niket, Aniket.
Yes, sir. Present.
Okay.
Present, sir.
Okay. Dev is present. Devasis is present. Shatrik is present. Gagandeep, Gaurav, Gitika, Gurmukh, Hari Jai Singh. Hari Jai Singh absent. Harish is present. Harmeet is present. Harsh Bajaj is present. Harshit. Hemang Joshi is present. Himani. Inayat is present. Ishu is present. JV Reddy. JV Reddy. JV Reddy. No. ये सिर्फ एक क्लास अटेंड किया है. JV Reddy, Sarvan Kumar. Karanveer is present. Satish is present. Harish is present. Lokesh present. Manisha is present. Manshul present. Danish is present. Mohit is present. Naman Gupta is present. Narendra is present. Naresh is present. Navdeep is present. Neeraj is present, Nikhil is present, Nikita is present, Nilesh is present, Nitesh, Nitin, Meena, Nitesh, Nitin, Meena, ये भी एक दिन है. Nitesh Singh Solanki is present, Om Shiv is present, Vinay Babu is present, Prachi is present, Pratibha is present, Radha Mohan present, Raghvendra is present,